Hey, folks! Welcome back to our channel. Today, we're going to talk about one of the most fascinating fields in science, fusion energy. This technology has the potential to solve some of the world's most pressing problems and transform our energy landscape. But what is fusion energy, how does it work, and what are the current projects and breakthroughs in the field? In this video, we'll answer all these questions and more. So, buckle up and let's dive into the world of fusion energy. But before we get started, did you know that the energy released by a single fusion reaction is equivalent to the energy released by millions of chemical reactions? That's right, fusion is an incredibly powerful energy source. Maybe that's why it's called fusion, because it fuses together tiny atoms to create massive amounts of energy.
Fusion energy is an incredibly powerful source of energy that is produced through the fusion of atomic nuclei. This process occurs naturally in stars like our Sun and is responsible for the enormous amount of energy they emit.
To recreate this process on Earth, scientists use a device called a tokamak. The tokamak is a donut-shaped vessel that uses strong magnetic fields to confine a plasma of hydrogen isotopes, such as deuterium and tritium, at incredibly high temperatures and pressures.
The plasma in the tokamak is heated to millions of degrees Celsius, creating a state of matter where the electrons are stripped away from the atomic nuclei, forming a soup of charged particles. The high temperature and pressure cause the nuclei to move at incredibly high speeds and collide with each other. When two nuclei collide, they can overcome their natural repulsion and fuse together, releasing a massive amount of energy in the process.
The energy released by fusion is in the form of light and heat, which can be converted into electricity using conventional power generation techniques. Unlike traditional sources of energy, such as fossil fuels, fusion energy produces no greenhouse gas emissions or radioactive waste, making it an incredibly clean and sustainable source of energy.
However, achieving controlled fusion on Earth is a complex and challenging task. To create a self-sustaining fusion reaction, scientists need to overcome several technical challenges, such as maintaining the plasma at high temperatures and pressures for extended periods of time, controlling the flow of the plasma, and developing materials that can withstand the extreme conditions inside the tokamak.
Despite these challenges, scientists have made significant progress in recent years in developing fusion technology. The International Thermonuclear Experimental Reactor, ITER, a large-scale tokamak under construction in France, is expected to demonstrate the feasibility of fusion energy as a sustainable source of energy.
In conclusion, fusion energy is a promising and exciting field of science that has the potential to transform our energy landscape and provide a sustainable and clean source of energy for generations to come. With continued research and development, fusion energy could help us address some of the world's most pressing challenges, including climate change and energy security. As mentioned earlier, ITER is one of the most exciting projects in the field of fusion energy. The aim of ITER is to demonstrate the technical feasibility of fusion energy as a sustainable and clean source of energy. ITER is a joint project between 35 countries, including the European Union, China, India, Japan, Russia, South Korea, and the United States.
The construction of ITER began in 2010, and it is expected to be operational by 2025. The project has faced several technical and financial challenges, but scientists remain optimistic that it will be a significant milestone in the development of fusion energy.
ITER will be the largest tokamak ever built, with a diameter of 30 meters and a height of 50 meters. The device will produce a plasma that is 10 times hotter than the core of the Sun and will generate a fusion power of 500 megawatts. The aim of ITER is to demonstrate that fusion energy can be generated sustainably and efficiently and to pave the way for the development of commercial fusion reactors.
In addition to ITER, researchers are also exploring new technologies and materials to make fusion energy more efficient and cost-effective. One of the most promising areas of research is the development of high-temperature superconductors. These materials can conduct electricity with zero resistance at very high temperatures, enabling the creation of stronger magnetic fields that can confine the plasma more effectively.
Another breakthrough in the field of fusion energy is the use of artificial intelligence, AI, to optimize the performance of tokamaks. AI algorithms can analyze vast amounts of data from sensors and simulations to optimize the design and operation of the tokamak, leading to more efficient and stable fusion reactions.
Overall, the current projects and breakthroughs in the field of fusion energy are incredibly exciting and hold immense promise for the future. While there are still technical and financial challenges to overcome, the progress made in recent years has been significant, and researchers remain optimistic that fusion energy will become a viable and sustainable source of energy in the near future.
Developing a self-sustaining fusion reaction is one of the most significant challenges facing fusion energy. To achieve this goal, researchers must create conditions in which the plasma in the tokamak can produce more energy than it consumes. This state is known as ignition, and it is the holy grail of fusion energy research.
The main obstacle to achieving ignition is that the plasma must be heated to incredibly high temperatures, around 150 million degrees Celsius. At this temperature, the hydrogen isotopes become ionized, and their nuclei can fuse together. However, containing such a hot and volatile plasma is a daunting task, as it can easily melt through any material that comes into contact with it.
To overcome this challenge, researchers are experimenting with different techniques to confine and stabilize the plasma. One approach is to use magnetic fields to contain the plasma in a toroidal shape, such as in a tokamak. Another approach is to use lasers to heat the plasma and initiate fusion. However, both methods require significant technological advancements to reach ignition.
Another challenge facing fusion energy is the cost of building and operating a fusion power plant. Currently, the cost of building a tokamak and operating it is very high, which makes fusion energy more expensive than traditional sources of energy, such as fossil fuels or nuclear power. However, the cost of fusion energy has been decreasing over the years, and as the technology becomes more advanced and streamlined, it is expected to become more cost-effective.
One of the factors that contribute to the high cost of fusion energy is the complexity of the technology involved. Tokamaks require sophisticated engineering and precision manufacturing, which makes them expensive to build and maintain. Additionally, the fuel used in fusion reactions, such as deuterium and tritium, is also expensive and can be difficult to obtain.
Despite these challenges, the potential benefits of fusion energy are enormous. If we can overcome these obstacles, fusion energy could provide a virtually limitless source of clean, sustainable energy. It has the potential to revolutionize the energy landscape and reduce our dependence on fossil fuels, which would have a significant positive impact on the environment and the economy. Therefore, the pursuit of fusion energy is essential for a sustainable future.